Hi, this video is for the lesson BAC is BAD, Bad News, Choosing a Function to Model Data. This is from the topic titled Using Exponential Equations. The learning goals for this lesson are to determine an appropriate regression equation for a given data set, to solve a complex problem using a mathematical modeling process, and to reflect upon that process. You can determine a regression equation for a given data set. Then you can use the knowledge to solve a real-world problem or to answer questions about the scenario. It is often difficult when you're given a data set to determine the type of regression that best fits the data. But when you calculate and graph the regression equations for different functions, then you can determine which of those functions is the best fit. For example, look at this table below. This represents the number of cell phone subscribers in a small town of Springfield over time. So we can kind of see that the number of cell phone users has increased drastically since 1985. So it's giving us different increments of years past that date. And we can look and notice that it doesn't look like it's increasing at a constant rate. So it might not be linear, but we're going to go ahead and do a linear regression to be sure. It does look like it's growing at a pretty fast rate, so maybe it's exponential. So I'm going to use graphing technology to help me. So I've actually created a table of values to create a scatter plot, and sure enough, my data looks curved. But you might think maybe it looks a little linear. So let me go ahead and do a linear regression. And the red line represents the line as the best fit for the data. I can see here that it's giving me what the slope would be and the y-intercept would be. And my correlation coefficient says that it's a pretty good fit for the data, but there's probably a better fit. So if I now do an exponential regression, I could see, wow, I now have a perfect fit because my correlation coefficient is 1. So it is a tight fit to this exponential curve. I can see there my A value. So that would be the starting amount is 285, which I see that in my data. If 1985, I had 285 users. I can also see here that it gives me the growth rate every year by this 1.75 or 1 in 75 hundredths. So I can see what's happening to the number of cell phone users over time. So now that I have that information, I can actually now analyze the representations to really notice some more things, to make predictions. I can use the graph to do that. I can use the equation to produce tables to extend my table of values. I could predict for future years, and this is all making predictions, or I could even then try to use the population here of cell phone users in a small town to now make predictions about the state or the country. Okay, I can even answer questions that come up or dig deeper and find some other things that I might want to analyze about using this data. Now, the modeling process is something you're going to see come up in this lesson. And it might be, when you hear the steps, it might sound very familiar to you. This might be things that you're already doing when you're problem solving. But modeling is the process of choosing appropriate mathematical tools to analyze and understand real-world phenomena and to make decisions accordingly. So let's look at this 5-step process. The first step is to notice and wonder. So this is where you're gathering information and noticing patterns, kind of like what we did in the table of the cell phone users. We could see over time that that population was increasing, but not really at a constant rate, at a much faster rate. So we're formulating mathematical questions about what we notice. Then we move into organizing and mathematizing. And so when we organize our information and represent it using different representations or notations, then we start to see some patterning happening. And maybe we're answering questions, or we're moving now into predicting and analyzing now that we've organized our data. When we predict and analyze, we extend the patterns that were originally there or that we created and complete operations, make predictions, and analyze the math results. So those are all things that we're starting to do, that we're digging deeper into the math. And then we might test and interpret. We're interpreting our results and testing our mathematical predictions in the real world. And we're making adjustments as necessary. Does it make sense? If it doesn't make sense, do I need to go back to any previous step to rethink or to readjust? And once we've really kind of finalized those ideas and interpret our results, then we're ready to report out. So this process is something that you will see and reflect upon in the actual lesson. In the lesson, you're going to be asked to make sense of some given information. For instance, they're going to talk about blood alcohol content levels. blood alcohol content levels, or BAC, is a way of measuring the amount of alcohol in a person's bloodstream. So that is given to you in percentages when we talk about that. But they're not going to tell you about a study that shows that a person with no alcohol in their blood system, so their BAC level is 0, they actually have a 1.8% chance of causing a car accident. So it's not 0%, because there's still some chance we're going to cause a car accident even though we have not been drinking alcohol. But what we really want to investigate is, as the person's blood alcohol content increases, how does the probability or the chance they can cause a car accident increase? So you'll be given some information to with the table of values to extend that table of values. They're going to ask you to create additional models. Think about which function would be the best fit. Can we use a regression to find the function or find the equation? Can we use that to predict? Can we graph that? Can we answer questions? And it even asks you to write an article to report out your conclusions. So just realize that in this lesson, you are using that modeling process that's been introduced, but they're going to ask you to think about, well, which part of the process were you in each step along the way? Remember, this modeling process provides you a structure to help you become a better problem solver.